Greetings, math fans. All right, so this is note sheet for day 3 for counting. All right, so let's basically what we're talking about today is permutations. Okay, this is the key here. So I'm just going to highlight this guy. It's permutations. All right, so a permutation is an arrangement of a set of objects in a particular order. Okay, that's huge. A particular order. Huge, 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 huge. Okay. Important features. Repetition is never allowed. Very important. Repetition. And any element can be placed in any position. Okay? That's kind of what that means, particular order. Any element can be placed in any position. Some key words. Again, this is really important too. When you see it, you see like the word arranged or ordered. You know there's some sort of order involved, obviously. Okay? The notation for this is NPR, National Public Radio. Just kidding, but it is NPR. Okay, P means permutation. N is the number of items you are choosing from. R is the number of items you're actually choosing. Okay, so you have a pool of things to choose from. That's N, and then how many am I choosing from that pool is R. All right. Some of these problems can also be done using the slot method. So let's just kind of get into a nice example here. Given the set ABC, find all different orders of 3 letters. These are permutations of the set. Okay? And so think about it. It's 3 letters. Again, no repeats. So let's actually do the slot method first. Okay? If there are 3 letters and I'm using all of them, do you guys agree the first letter in that slot is going to be 3? No repeats. That means I can't use it the one I used, so it's down to 2 and then 1. Okay? And 3 times 2 times 1, of course, is 6. Now, if you do 3p3 on your calculator, okay, and where you find this, here, let me show you the calculator real quickly. Okay, so I got my TI up here, and basically what you're going to do is you hit math, and I always hit the left arrow because you got to go to PRB. Okay, you could hit the right arrow 3 times, or you could hit the left arrow once, and then NPR is number 2. Okay, NPR. Well, what we need to do first is actually type in 3p3. So it's going to be 3 math NPR, which is 2, and then 3. So this one says I'm using 3 letters that I have, and I'm using all of them. So I have 3 letters in a pool. I'm using all 3, and that should give you 6. Sweet. Okay. So the next one, given a set of A, B, C, D, E, list the permutations of 5 elements taken 2 at a time. So again, let's use the slot method. Again, you can't do repeats. So we're using, the first time I do it, I have 5. And then I have 4. You guys agree with that? So that's 20. And if I do 5p2, I have 5 math p2. And hopefully that gives us 20. And voila, it does. Okay? So this is 20. All right, so again, it's a particular order. So in other words, when I say a particular order, it could be A, B, C, D, E. It could be A, C, B, E, D, right? It's a specific order. That's what a permutation is. Example 3, there are 11 schools in a conference. How many different ways can 11 schools finish first, second, and third in the conference for baseball? Well, I'm using a permutation, and I'm saying I'm choosing I have 11, and I need to figure first, second, third, so 3. So 11p3 gives us 990. Okay? Pretty easy. Just again, you're using your calculator. Okay, so factorial. Well, basically what factorial is, I put some examples here. If I say n factorial, that means you take every number from that number and you multiply the integers all the way down to 1. That's basically what it is. So right here you see 4 factorial is 4 times 3 times 2 times 1. Okay, that's this guy right here. And that's equal to 24. It's pretty easy. 6 factorial is 6 times 5, 4, 3, 2, 1. That gives us 720. 1 factorial is just like saying 1. Now 0 factorial, and that I even have a little thing here. It says by definition. Okay, because truly you don't really have a 0 factorial. You can't say times 0 because everything would be 0, right? So by a definition, 0 factorial is 1. Okay? And if I want to look at that on our calculator, see it says TI-84, go to math, PRB4. So let's go bring up our TI. If I hit math, go back to PRB, so left, and there's the exclamation point, or the factorial, 4. So if I want to use that, if I want to say 5 math and 4, so 5 factorial, that should give us 5 times 4 times 3 times 2 times 1, which is 120. Oh yeah, there it is. Okay? Not bad. Now we have a nice little friendly formula to figure out the number of permutations. The number of permutations given by the formula is really what your calculator uses. It's NPR. This is just another way to write it right here. Okay? But anyway, this is your formula, math fans. You guys need to know that. All right? So you use this formula using, in this case here, we're using sum of the items. All right? Actually, there's two formulas. I only show you one. There's another one that sometimes is shown. And if I am using all of the items, think about that. That R means I'm using all the items. And if I use all the items, my formula would actually be n factorial over n minus r. So it would be, I'm using all of them, so it's like n minus n factorial. Okay? And that's like saying n factorial over 1 factorial, or just n factorial, right? Okay, but we're not going to use that separate formula. We're just going to keep one formula in our brains, and it just makes it a lot easier if you have just the one formula, okay? But it's n factorial over n minus r factorial. Another thing to know is, it says permutations with repetitions. The number of permutations of n objects, which are p are alike and q are alike, is n factorial over, and these are this p factorial, q factorial are the basically things that are duplicated or triples or four times. Okay, I have an example using these, but you definitely have to know these two equations. And this guy here is not really an equation; it's just understanding how to use this. Okay, so let's move down here. The first example, it says how many different arrangements can be made from the letters of the word trigonometry. So basically what you do here, math fans, if I count the number of letters in trigonometry, you would see it's actually 12 letters. So it's 12 factorial over, and then you're looking for letters that are repeated. Well, do you guys agree that there are 2 T's, so that's repeated twice. There are 2 O's, so 2 of those, and there are what else do I have here? 2 T's, 2 R's, and 2 O's. Okay, so this is really what I have. The key here, math fans, you got to use parentheses. That's huge. If you don't use parentheses, you say 12 factorial divided by 2 factorial times 2 factorial. What happens is it'll divide the first one by 2 factorial, but then it'll multiply the rest of it by 2 factorial, 2 factorial. Got to use parentheses. And I type that in my calculator, I get 59,875,200. Okay. Oh wow, it's a good batch. It's the exact amount that I have in my checking account at the current moment. Or is that negative? I can't remember. Okay. Anyway, that is how you figure that out as far as how many ways you can arrange that. The reason we're dividing it by duplicates is because, think about it, if I actually wrote trigonometry and the reason I, again, divide it by that 2 factorial is because if I switch that R and that R, it doesn't matter. It's like I'm getting rid of those duplicates. If I switch the T and the T, it doesn't matter, right? Okay, so that's why I'm dividing it by those the factorial to get rid of the duplicates. All right, this next one is 5 factorial divided by 3 factorial, and I want to explain what this actually does. If I do 5 factorial, it's 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Do you guys agree with that? So the 3's cancel, the 2's cancel, of course 1's kind of cancel, and I got 5 times 4, which is 20. That's pretty easy. And if I did on my calculator, so 5 factorial divided by 3 factorial. So 5 factorial divided by, I don't need any parentheses here, 3 factorial gives me, voila, 20. Okay. All right, so I want you to type this one in our calculator. So 5 factorial divided by 499. So watch this. Or 500. So 500 factorial divided by 499 factorial. Brutal! Overflow error. You guys need to understand, 500 factorial is an enormous number. It is huge. Okay, so what's going on here, math fans, is that it can't handle it. Can't handle that huge number, and it gives you an error. So, but you got to think logically what that means. If I do 500 factorial, isn't that 500 times 499 times 498, etc., over 499 factorial, which is 499 times 498. Keep going, keep going. Okay, the 498s cancel 499s. So truly, math fans, the answer to this problem is 500. Even though the calculator can't figure it out, it's going to be 500, right? Because you know it's going down by 1, and that top one is 1 more than the bottom. So it's 500. All right, this next one, you got to put in parentheses. If you don't put in parentheses, you're going to get it wrong. So it's 7. Let's bring the calculator up here. 7 factorial divided by parentheses 4 factorial times 3 factorial. Close parenthesis. Okay, hit enter, and we got 35. Okay, pretty easy. Again, this one won't work. 1,049, huge number. But, of course, the one below it is less, so what's our answer? 1 over 1,050. Okay, not bad. All right, find n when Pn5 equals 12. This is a little time symbol here. It's what you have on your paper. When NP5 equals 12 times NP3. That's why you have to know the formula. You can't just always rely on your calculator. All right, so we're going to do n factorial. Let's kind of write it out. NP5 is really n factorial over n minus 5 factorial. Okay, and that's 12. And again, it's NP3, so it's going to be n factorial over n minus 3 factorial. That's really what you have, and you're trying to solve for n. Well, I want you guys to understand that they both have n factorial and n factorial on top. So I can multiply both sides by 1 over n factorial, right? Like those were basically, they just cancel out. And so now what I can do is, if I cross multiply, I get 12 times n minus 5 factorial equals n minus 3 factorial. And then let's get the 12 by itself. So I get 12 equals n minus 3 factorial over n minus 5 factorial. So n minus 3 factorial, remember it's n minus 3. Don't forget the first one. N minus 3, then n minus 4, and then n minus 5, and you keep going. And n minus 5 is n minus 5, n minus 6, so that keeps going down. So everything cancels except for n minus 3, n minus 4. So really what you have is, I still need to solve for n. You can't set that equal to 12. Each one equals 12. If it's equal to 0, you could do that. So what you're going to do is you're going to do n squared minus 7n plus 12 equals 12. So you get n squared minus 7n equals 0. So n times n minus 7 equals 0. So n equals 0, n equals 7. So you got two answers. But think logically. Okay, n can't be 0. Because you can't say, oh, I have 0 items. I mean, look at this first one, NP5. I can't say I have 0 items. How many ways am I going to pick 5? That doesn't make sense. Okay, so the answer actually is just going to be this, n equals 7. All right, so very important. Okay, so let's keep going here. N plus 3 factorial over n. Well, again, what you need to remember is n plus 3 is the same thing as saying n plus 3, and you keep going down. N plus 2, n plus 1, n minus 1, blah, 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 blah. And n factorial is n times n minus 1 times n minus 2, so blah, 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 blah. And you can tell all this cancels. The n minus 1's cancel, the n's cancel, and my answer is just n plus 3 times n plus 2 times n plus 1. Okay? Okay, n minus 2 factorial. Remember, that's like saying n minus 2, and then n minus 3, and n minus 4. Keep going. N factorial is n times n minus 1 times n minus 2 times n minus 3. I'll keep going. And so the n minus 3's cancel, the n minus 2's cancel, and we have 1 over n times n minus 1. Okay, and you can leave it like this too. You don't need to multiply that out in the denominator. All right, this next problem, I'm trying to find a common denominator. All right, and I want you to understand, first of all, which one do I need to actually multiply something by? Because isn't n plus 1 the same thing as n plus 1 times n minus 1? And n factorial is n times n minus 1 times n minus 2. Keep going. So really, the only thing that this one doesn't have, it doesn't have an n plus 1. So what I need to do is I multiply n plus 1 over n plus 1. Okay? If I do that, I get n plus 1 on top, and I get n plus 1 times n, which is just n plus 1 factorial. That's why I'm trying to get to the same number as that, and the same denominator, right? And then, of course, it's still at plus 1. So I wind up with n plus 2 over n plus 1 factorial. Okay? If you don't understand what that with variables, let's just check it out with numbers. I'm going to erase this a little bit here so we can kind of see a couple of things here. Okay. So let's think of it as a number. If I do 1 over 5 factorial plus 1 over 6 factorial, you guys agree with that? Because it's n plus 1. Well, isn't this 6 times 5 times 4 times 3 all the way down? And this is 5 times 4, 4 times 3 times all the way down. Okay, so what does this one need? Well, this one has a 6, so this one needs 6 over 6, doesn't it? Because if I multiply this out, 6 times 5 times 4 times 3 isn't the same thing as 6 factorial? Okay, so that's why in the problem I multiply the top and the bottom by n plus 1 over n plus 1, one above it, and then that's how I got the n plus 1 factorial. Okay, well, it's a little tricky, but you know, that n factorial right here, math fans, is really n minus 1, n minus 2. So when I do n plus 1 factorial, it's really n plus 1 times n minus 1. And your n minus, this I'm trying to pick up, I need to pick up an extra n plus 1 for this. That's basically what the deal is. Okay, and I try to show you this example with a 6. I have a 6 factorial here, so I need to pick up an n plus 1, a 5 plus 1, or a 6 there. So I multiply the top and bottom by 6 over 6. Okay? All right, so let's do some nice little friendly examples here now. In how many ways can the word Mississippi be scrambled? Well, how many letters in Mississippi? There are 11. Okay, and what's repeated? There are 4 S's. There are 4 I's. And there are 2 P's. So again, make sure you use parentheses in the bottom, and you get 34,650. Okay? All right, these next few problems are bride-groom problems. Great, great problems. I love these problems. Bride and groom are taking a picture with their wedding party. There are 8 people in the wedding party, plus the bride and the groom. How many ways can a picture be taken if the following are true? Okay, the bride and the groom must stand in the middle of the group with the bride to the right of the groom. So here's the deal. I've got that. The bride is to the right of the groom. And then that. And they must stand in the middle. So do you guys agree that these 8 blanks around it, anybody can stand anywhere? So that means there are 8 to choose from, and that means it's 8p8. Okay? And the bride and the groom, they're in the middle, and they're in a fixed position, so that's why there's no additional work involved here. 8p8 is 40,320. All right, B. The bride and the groom must stand in the middle of the group. The couple can stand in any order. It's the exact same thing as the top one, except now I have 2 slots here. We'll say groom and bride, and 1, 2, 3, 4. So it's still the same thing. It's 8p8, but I also multiply that by, because it's and, how many ways can I arrange the groom and the bride? Well, there are 2 there, and I'm using all 2 of them, right? So isn't that 2p2? And some of you guys, you can actually say, well, isn't that just the bride can be in one spot, and then the bride can be in the other spot for another picture? So it's really 2. You're multiplying it by 2. That's exactly what this is. It's multiplying it by 2. But I want you to learn it as a permutation, as opposed to just going, oh, I'm just going to multiply it by 2. Because if you have 3, if let's say you have Fido in the picture, okay, which I think is similar to what your homework is, then you have 3 things to arrange. All right. Anyway, if I multiply 8p8 times 2p2, I get 80,640. Okay. Here's this one. Anyone can stand anywhere. So 1, 2, 3, 4. Bride and groom. 1, 2, 3, 4. But anybody can stand anywhere. So that's just going to be 10p10. Which is 3,628,800. Okay, the bride and the groom can stand anywhere, but must be next to each other. So here's the deal. The bride and the groom are 1 slot. And then I have 8 more. Okay, so that counts as 1 slot here. So that means really it's 9p9, right? Because it's 8 bridesmaids and groomsmen. And then the bride and groom can also be a slot there. So it's 9p9, but the bride and groom can stand anywhere they want as far as left or right of each other. So that's why it's times 2p2. Okay, and that gives you 725,760. 725,760. Okay, that's D. Okay, and E, the bride and the groom must stand in the middle in any order. So let's do that one. The bride and the groom must stand in the middle in any order. So 1, 2, 3, 4. Here's the bride and the groom. And 1, 2, 3, 4. And the 4 groomsmen must stand next to each other in any order, and the 4 bridesmaids must stand next to each other in any order. So here's the deal. This 4 set of slots here is 4p4. Because they can't just stand anywhere. It's the groomsmen have to stand in a certain place. The bridesmaids have to stand in a certain place. They have to stand in the middle, so this is not a slot here. But what do you have here? Okay, that's 2p2, right? So that's 2p2. Are we done here? Actually not, because can't the bridesmaids and the groomsmen, can't they switch sides as well? So it's really times another 2p2. And so it's 2p4, 2p2, 2p4, 2p2. You multiply all that together, and you get 2304, 2,304 ways. Okay? So that's it. It's a good problem. Got some good bride and groom problems, but this is all permutations, which means order is important. All right? No repetition, and order is important. Very, very important. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.